Hello everyone, here is a question based on chemical bonding. Histidine is an amino acid. The 2D structure of histidine is given. In that case, what are the approximate bond angles at 1, 2 and 3? If we figure out the hybridization in these 3 different places, we can find out the approximate bond angles and we can choose the correct answer. Here we see a carbon-carbon double bond at 1 and therefore this carbon atom has to be sp2 hybridized and this one also sp2 hybridized. Here we are worried about the bond angle of the nitrogen, carbon, hydrogen. Therefore, that will be 120 degree. At 2 for this nitrogen the hybridization will be sp3 and for this carbon the hybridization will be sp3. However, nitrogen has to have a lone pair. Just because it is not shown in the structure, it does not mean that the lone pair does not exist, because we know that the atomic number of nitrogen is 7 and therefore the electronic configuration is 1s2, 2s2, 2p3. When nitrogen undergoes sp3 hybridization, we will have 4 equivalent sp3 hybridized orbitals. Among them, one of them will be paired and that is the lone pair, and the other 3 accounts for the bond pair. Therefore, we will have lone pair bond pair repulsion here. This means that it cannot have the ideal bond angle of 109 degree 28 minutes. It will be slightly less than that, and therefore we can take the bond angle as 107 degree here. And for 3 we have only bond pairs and therefore here we can take it as 109.5 degree. Therefore, option C is correct. Let me show the structure of histidine in 3D compared to 2D so that this would make much more sense. Here we are talking about the hybridization of this carbon, that is 1, and this nitrogen, that is 2, and this carbon, that is 3. We have lots of carbon-carbon single bonds here and carbon-nitrogen single bond. All these things can get involved in free rotation, and that is why when you compare 2D structure with the 3D structure, it would be quite different. So, here the bond angle is 120 degree and here because of the lone pair bond pair repulsion, the bond angle will be 107 degree, and here we have only bond pair repulsion. Therefore, the bond angle will be 109.5 degrees, because the number of valence electrons for carbon is only 4. In the case of nitrogen we have 5 valence electrons, in the case of carbon we have only 4 valence electrons.